Hello colleagues, my name is Alexander Zelenin. I am software engineer for over 15 years. Today we will go through word break problem on LeetCode. I will show you the fastest algorithm on LeetCode platform. I had observed a couple of them. I had observed the one that marked as bestest one, but actually they were not. So I had write the one that is faster than all previous one. Maybe there was something similar to this one, but on all explanation, not best algorithm are provided. So this is better. I am currently located in UAE, in Dubai. So let's go take a look at the problem itself and understand what we need to do. So problem called word break. So we have non-empty string and dictionary containing list of non-empty words. We need to determine can we segment our initial string by this word or not. And we can use the same word multiple times. So, and we can assume that dictionary do not have duplicated words. So, for example, if we have a string leetcode and the dictionary with two words, leet and code, we should output true since it's possible to write this by exactly dictionary words. I'm from Russia originally. So let's take a look at another example. Apple, pen, apple. We have dictionary of two words, apple and pen. So we can create the original string with these two words, apple, then pen, and then apple again. So it's possible. And the last example here is cats and og. So it's not dog, cats and og. Let me select it. And we have words cats, dog, sand, not, and cat. So there is a lot of possibilities, and we should output false in this case, because it's not possible to write this word. For example, we have cats. If we use cats, we left only with and og. There is no word og, so for example, we take og, so we left only with n, and there is no n in our dictionary. So we cannot create this string only from our dictionary, so we should output false. Maybe it looks not so complicated right now, but let's observe the problem and observe what options we have to do this. So let's go to design step. Let me type a bit. So let's start with word leetcode. And also we have dictionary. Maybe let me type it also here. So leet and code. So, okay. We can how we can solve this problem as humans. First of all, we can observe the dictionary itself and start to find which word is work for us, and then try all possible combinations later on. So we start with the first word leet, and we can see that this word exists here. So we end up with the next option. We have left with letter C, and we can find next item in our dictionary, which is code. So yes, we can create this string. My main programming language is JavaScript, but I had to write on dozens of languages from assembler up to JavaScript. And usually at work I use a lot of languages like Java, Python, sometimes C#, Ruby, PHP, JavaScript, and so on. But my favorite is JavaScript. Okay, so let's take a look at another example that we have here. The one that cats and dog. And here we have much... one second. And here we have much more options to take a look. Yep. So we can start with the letter C. And for letter C, we already have at least two options. So which one we can choose? We can choose cats and get this one, or we can choose cat and get only cat. So after this one, for example, we go with the cat, like with smaller one. We start with the letter S, so we left with the send only, since only send start with the S letter. So we can go with the send in this case, and then we left with the OG. For OG we don't have an option, so this is not work. When we go with the cats, so we go with cats, we have letter A, and for letter A we have only and here. So we took this and we still left with OG. Or we can go with another approach, and for example we can take dog to an end. But anyway, we left with something that is not in our dictionary. So like what is complexity of this approach of trying every time, like every possibility? So let's calculate it. So we start with the first letter, and we finding for the word in or all words in our dictionary that start with this letter. In worst case, all words in our dictionary will start with this letter. So for example, all of them will start with letter C, and there will be a lot of options. So let the length of one second. Let me just check which letters I had used in the description. So let's D will be count of letters in our dictionary. Let's L will be length of the one letter that have like longest length. And N will be count of symbols of our original string. In this case, so for first letter, we have all options in our dictionary. And from first letter, we can start with every option. We can go to some part of the word of this initial string and initiate, repeat this operation multiple times. In this case, we will have a very huge complexity, since we need to repeat this operation and go like deeper and deeper, and in some cases we will repeat operation. For example, if we'll have word like k and ts, and we have word cats as one word, and for example we have also cat and word just one letter s, all of them leads to same position, so we don't need to calculate this and like start with s with different approaches. We need only one approach from this position. Like, we knew that we can make this word, and that's enough for us. So what will be complexity if we try to repeat operation every time and make like branches for all possibilities? So let's assume that we have a string like a without commas, so like this, and we have a dictionary where we have different possibilities with same letter. Okay, so in this case at start we will have 4 options: 1, 2, 3, 4. After first options we will end up with the second symbol. After second one we will need to start on the third one. After this one we will start on fourth one. After this we will start with fifth one. So we start like 4 new chains at this position, and for every chain we repeat this operation. So at this position we will still have another 4 options, like here, 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 and here, right? So I need to skip one letter. Yeah, right. So like this. And with the next letter we will repeat this operation, so it will be very deep chain and with a lot of repetition. In this case, for every letter n, we will start a new chain with the d possibilities. So we start like 4 operation, and second step we will start another 4. On third step we will more and more of them. So I'm not sure which complexity will be here. Maybe something like nk, or I'm not sure exactly. But okay, let's assume we don't perform operation on the same letters. What will be complexity in this case? In this case, we will have a complexity of n square dl. So we will go through our string 2 times. Not 2 times, sorry. For every letter we will go with all other letters, and we will go with every word in our dictionary for up to same length as this word. So because every letter need to be like compared with the original string. So let's go to the code, and then we will go back to optimize step. So let me show this one. This is the approach that currently on LeetCode market as fastest one. So this approach is fastest one on LeetCode right now, but a bit later I will show my approach that faster, and I will show tests like how faster it is. So first of all, this condition is unnecessary, but it doesn't change anything. It's like if a dictionary is empty, we just return false. So this algorithm create new array by the size of original string plus one symbol. Fill this array with falses, so we'll have like array of falses. And the first value we mark as true. Like this, we will start with the first symbol, so we mark it as true. Also, I think there is possible one thing that will break the cases, but okay, doesn't matter for now. I will check it later. So we go through every letter from the first one to the last one. We will work with the length first, and inside of this array we are going from 0 to the same size of length. So in code we will check next thing, that first of all at this index we have true, like this. So for J0 it will be true because we initially have true. And later on we check our dictionary by includes function. Includes function go through array and find that some value is exist. And we provide to this function substring of original string from J, from like this symbol, to I length. And when I saw this, I was shocked. Why this algorithm is fastest? Because substring itself has complexity of n. Includes function have complexity of n, so it's already a n square here, and we have another n square at this position. So there is different variables. Originally there is complexity will be, let me write down for this algorithm, is n square dl, where let me just copy from description this part, from description of this video. So first we create the array. It's just on, so it's not a heavy operation, it's fine. Filling it's also on, so it's also not heavy operation. Fine, that's fine. Then we go through our string with two iterators. So this one is n square. These two loops give us n square. Then we have includes function and substring function. Substring function is up to, in our case, is up to L. So this operation take L time, and then later on includes take another D time. So it take D to L. So, and this happens inside of the loop that give us n square. So it's like dl. And with this, like how it even can be fastest algorithm, right? It can be not. So let's go back to design step, but to like optimize step, and take a look what I propose here. So let me just remove everything from the desk and provide examples from the Scratch. 1 second. So we have cats and dog, and we have this array. Okay. So My idea initially was similar to the fastest one with the array. So we will have some array where we will have some kind of cache, some kind of caching by calculating thus we have calculated to some place. But with the dictionary itself, I prefer to work with like a tree. So from the dictionary, let's create a tree by every letter, and let's take a look what we'll have. So from cats, we will have a dictionary like C, A, sorry, not dictionary, but tree. Cats, and then we will have a result here at this place. Then for dog, we also create dictionary, create a tree, sorry. So we do it for every word, but the different is next. For the same word, like cat, we go through already existed word and mark our letter T as existed one. So in this tree, we will have two options. Okay, so we store just once for same words. So for example, if we will have if we will have a string like we will end up with just one tree with 4 letters. So A, and we will have result on every leaf of this tree. It's not leaf exactly, but on every letter. So okay, so we transform our dictionary to tree. I hope at this point it's clear enough. After this, we starting with the first letter. So we start with C. We start with C, and we see there is like main node of all of them. So we go to letter C, and we see that we have cats here. So we start going by every letter. So initially we have, let me use just like this for letters where we have true. So remember that in array we have true or false. So for the first letter we always have true, we set it initially. So we start going through our dictionary, and same time we start skipping letters. So we go for next letter, we see that we have A here. So we find in this dictionary for A, in this tree, after node C. Then we go for T, and we go for T. We see that we have answer here, so we mark the T as a completed one. Originally I mark not the T, but next letter after T, so like this. It means that we can start with from the next letter. Then we go to next letter, to S. We also have S here, so we have result. So we marking next one also as existed. Then we go to next letter, to A. There is no A, so we stop this operation in our tree and we start looking for a new tree. And we have tree A and D. Okay, that's the only tree that starts with letter A. Let me change color to another one. Okay, yeah, like this. So we go to N, we go to D, and here we have an answer. So we mark O as possible next start. We doesn't have any other options for end, so we end up with OG. We doesn't have anything on O, So at this point we knew that we doesn't have an answer. Okay, let me repeat it quickly for a case with a lot of A's, how it will work. So for example, we have a lot of A's. So what will happen in this case with my algorithm? So let me change color one more time. Yeah, so we have tree like this one. We start with the first letter and we go the same time by letters in our tree and by letters in our string. So we go to the first one and we find an answer. So we mark second one as existed. We go to we go through all of them. So 1, 2, 3, 4. 1, 2, 3, 4. We mark all of them as existed ones. Then we go to next letter here. We see that letter is already marked, so we can start with this one. And we perform same operation like 1, 2, 3, 4. For next one also 1, 2, 3, 4. So the idea here that instead of searching in the dictionary and comparing symbols and making substring and so on, we are working with a tree and we very efficiently go through every solution. So in the end, after the last symbol, we have the last one marked as true, so we knew that everything is fine. Whew, okay, let's go to code again and see how my solution looks like. So we have two functions. One function is to create a tree and another function is to break to find it is possible to break this word or not. Yes, it looks like more complicated than previous solution, but that is what we pay for optimizations. Sometimes we pay with additional memory, and sometimes we pay with more complicated code. So let's take a look at the create tree part. So create tree receiving as our argument our dictionary. So we go through our dictionary, we create new object, real dictionary, and for every word we start with the root node of our tree. And for every letter in our word, we go deeper and deeper in our tree, and we either go deeper, either we create the child node. After we go to the last letter, we mark this letter with result true, what means that we have some word that end at this position. So after we create a tree, that is first step, we creating an array of string length elements plus 1. The same as with previous algorithm. We mark the first one as true. Then we go through our string for every letter. We go for this letter, we're starting with this letter only if we have some result like availability to start with this letter. Then we have go through nodes in our tree. So we checking that the current position is still in the string, and this as car, maybe it will be better to rename it a bit differently, but that's fine. So string current represent current symbol. So if we have current symbol as next node, we go inside of this node. And if this node has result, we mark in our results the current plus 1 as true. Like we mark the next letter as possible start, and we increase this and repeat this operation until the end. So what complexity of this? For creating tree, we go through our dictionary. Let me just copy paste this part. For our tree, we go through our dictionary and through every word. So we will have complexity of d, count of words, multiplied by l, the length of the word itself. So we have ODL at this position for create tree, nothing else. Let me just put it here. Okay. So then we create a result, which result us to on. Then we go through the string. Going through string give us on complexity. Then, if there is result, we going through our nodes. In node, we will go up to L time. So, 1 second. Yep. So here we will go up to L time, and that's all, right? So at the end, we have complexity here of NL. So we have two operations. First one is DL and second one is NL. We can combine them, which give us complexity of DL plus NL, which is actually equal to L D plus N. Yep, like this. So just compare this complexity. So we go from N square DL to just LD plus N. So it's a significant result. We can now test our code. I prepare some tests, like some small benchmark. Let me show this benchmark and test the data that we will work with. So first, what we will start is test data. Is it visible? Yep. So we will create a string with just letters A. Remember, I told that this is like most complicated option. Then we'll have some count of dictionary items. Then we will have some length of every dictionary item. In our case, for our test, we'll have same length for every item, but it doesn't matter too much. So we creating our string, we creating our dictionary and put all values. The values in our dictionary will be like A, B, C, and so on. So later on it will maybe something like that. So we have a lot of combinations of our letters in our dictionary. Okay. This is test case that we will run. We also can adjust it to some values if you want me to test something special. And here is benchmark. There is also nothing special. We will provide to our benchmark our method arguments to these methods, how many times we want to run our benchmark. It will run that times this benchmark, get results, sort results, and got to minimum value, maximum value, average, median, total, and just in case we'll compare answers. Is they same or not? And we have a compare function just to see how many times the result, like the one option is faster than another one. Okay, so let's, I'm not sure, maybe I need to go to like debug step and let me open console. So I had the preload benchmark. Is it visible? Yep. I had preload benchmark, I had preload test cases, the optimal solution, which is my one, and the old one that is currently marked as fastest one. So I run benchmark, it will take some time, and we see that the answer of both of them are equal, and minimum value is about 20 times faster, maximum speed about 14 times faster, at average 15 times faster, so and so on. So we can see that this test case, in this case, we have significant result. It's 15 times. Just to ensure that, one second. Just to ensure that order doesn't matter here, let me run it one more time. So I change the order of them. So first of them is old one and second one is optimal one. The result will be different since like every time the result can be different. That's fine. We can also increase the count of runs just to be sure, but it doesn't matter a lot. So we can see that old one is slower by about 20 times, at maximum about 16 or 15, and in average about 20 times slower than optimal solution. We can play a bit with test cases. If you want, we can try to run it not with 10,000, but with some smaller values. And with smaller values, let me just prepare tests 1 second. With smaller smaller numbers, it is possible that the fastest solution is actually faster. And reason for this is optimizations that provided by the Node.js engine itself. So let's take a look at example. Oh, sorry, I write 10,000 time again. I want to make just 1,000. Just 1,000 operation. So for 1,000 operation, you can see that for minimum time, my algorithm is faster for just 2 times. And for maximum is 1.5. So you can see that on small values, let me repeat this test one more time for 100 elements. So for 100 elements, my algorithm is actually slower because we spend a lot of time by creating a tree and there is like not too much letters and so on. But my algorithm provides the stable time, which is like algorithmically better. So we can test also with something bigger, like 20,000 elements. What will be the difference? Let's take a look. So if we run for 20,000 elements, instead of 10,000. For 10,000, you remember there was like 15-20 times difference. For 20,000, we have already 30 times, from 30 to 40 times difference. So with the increasing values, we see that difference also significantly increase for every step. So something like that. For the values for about 100,000 elements, it just doesn't work for me. So I had tried to run old code on 100,000 elements, and that doesn't work at all. So let me just run one test case instead of 11. And try to see will it work or not. So for 100,000, let's see. What you're thinking about this generally? Leave comments. Like, what you prefer, to have a real algorithmical faster, or to give some possible optimization that you are not sure about to compiler itself. So you can see it still work. I have no idea how long ago I had run it, but I remember that just running my code, it took under 1 second, or about 200 milliseconds or so. So, but yep. So I will start this because it took too much time. So let me just show that for optimal, you see it's done already. So I just ran it few seconds, less than a second ago, and it's already calculated. So it's super fast. We can try with just 40,000 maybe. I'm not sure at which position it stopped working, at some some time that we can just wait here for now. Okay, even for 40,000 it took too long. I just ran one time benchmark, not multiple times as previous runs, but just one time, and it's still working. So at huge values, this complexity play a really bad trick with you, because with smaller one it can be looks like, oh, that's fine, but when the numbers increasing, that's instantly show how it works. Okay, let's go to an end of the stream. So let me open code here. So thank you for watching. Set like, subscribe, write efficient algorithms. Leave comments what you think about this type of videos when we try to find the best possible solution for something and explain why like best possible. So okay, thank you and have a nice day.